Hi, everybody. My name is Bess Ho. I'm the group leader for Silicon Valley Web Builder. Also, I do a lot of web community work for the Ruby and Rails community. So I really like to take the chance to thank Google and Googlers to help and support this event. Without them, this would not happen so quickly. And so I would like to personally thank John Woody and Isaac for helping out tonight. Thank you. I do like to make an announcement. So tonight we are covering Rails. In about 2 weeks, last Wednesday of this month, we also invited Jerry Spool. He's the principal and founder of User Interface Engineering Group, and he's one of the world-crowned expert in user interface. So if you're interested in that, please go check out the website from Silicon Valley Web Builder, which is http www.svwebbuilder.com. I have some cards over there that I'm going to pass out later if you wanted to find keep our website address. In August, we also have a meeting about celebration of Web 2.0 cultures and trends. In September, we have a very exciting meeting on Web 2.0. Actually, it's UI 2.0, and it's a very interesting discussion panel that we invite the top UI designer, engineer from FriendsFeed, Meeble, another very popular startup to join the discussion panel. It will be at AOL campus. October, we have another important discussion on HTML5 and reverse AJAX, which is called Comet. And we're going to go over some standard like WebSocket. So all this information you will find on our website. So I just want to get some sense on how many people are here to support Ruby, like a Ruby developer. Raise your hand. How about Rails? All right. How about first timer and trying to explore Ruby and Rails the first time? All right, welcome. Okay, so I'm going to let John to do the intro, and he's our MC and event coordinator tonight.
Hello. Yeah, and I'd like to also thank Jason for being here, Isaac Trotz, and Bessa, of course, for putting all this together. So I'm John Waddell, and I actually work on Rails apps inside Google here. Jason's actually one of my favorite speakers because he makes talking about load balancers and DTrace so exciting. So I hope he's going to share some of that with us with his talk, Ruby and Scalable Architectures. So let's welcome Jason. Thank you.
Thanks. Hey, well, good evening, everybody. Let me move that bottle down, too. So we have about a 60-ish slide, 45-minute-ish type of talk about Ruby and scalable architectures. Quite honestly, not too much of it is about Ruby, meaning that most of it is, in fact, applicable to everything else that's out there. It just so happens that we're probably writing a Ruby app. You're probably writing a Rails app. I mean, for example, how many people here are writing a Ruby app that is not in Rails? Okay. How many people are writing a Ruby app that's not in Merb? Okay. So what are you guys using? Your own stuff? Just a Ruby app. That's nice. So I first found Ruby myself when I was still doing academic things. I was down at UCSD in San Diego. And a lot of the infrastructure we were playing with at the time was basically being built on top of a BSD kernel. Just to give you a little quick history of how I found Ruby. And the interesting thing about FreeBSD is that the guy that became the sort of architect of the port system at that time, and his Twitter username is KNU. If you want to follow what he Twitters about, it's typically beer and music in Japanese. Also became the sort of release manager, CVS manager guy of a new scripting language called Ruby. And in 2001, he released like the first quote unquote killer Ruby application. And that was port upgrade on FreeBSD. So roughly at the time, 900 lines of Ruby became about 1,200 lines of Ruby of basically a nice fast script that managed all the software that you have installed on a FreeBSD system. And that's in fact how most people at that time found out about Ruby, was that lo and behold, a lot of the management tools in FreeBSD were Ruby based. So then, at least from my history, is that we were playing around with a lot of scripting inside Ruby and started getting more into the BioRuby after being in the BioPython project a lot. And we were doing some sort of side things in Ruby. And then for me at the time, I was also using a piece of software internally called the Copper Project, which is a piece of project management software, and got asked to beta test a new sort of online piece of project management software that was called Basecamp, just because I was on the endorsement page for this other thing. So I asked the single guy running Basecamp, like, well, this is actually pretty cool. What's it written in, just out of curiosity? And he said, well, I hired this sort of Danish kid in college as sort of a contract basis to sort of write a lot of the back end for like, $3-4 grand type of contract gig. So I was like, oh, that's pretty cool. What's his email address? I'd like to hear what he's doing. And reached out and started talking to David Hannemeyer Hansen at that time, and he was like, well, I'm thinking about actually coming out with a Ruby framework, and I'm going to call it Rails. And at the time, we talked a lot about licensing issues and some other things that were pretty neat. And then the funny thing about Rails is that when it was released, it was like July 24th or 26th in 2004. You can sort of go back to the old sort of Ruby language list, and you see a lot of things where the initial feedback is that this kid's done too much PHP and Java in his life. This looks nothing like Ruby. And Rails was an interesting thing because it was then basically being pushed by a smart guy who looked like a gap model, and it became synonymous with the language Ruby to a lot of people. And in fact, even a lot of Ruby applications that people are writing now look like Rails. They don't look like what Ruby looked like 4 years ago, 7 years ago, 8 years ago. They look completely different, follow a sort of completely different look. So that's a little bit of how I got into the Ruby stuff and the Rails stuff. There's also a shameless plug for myself in that I was interviewed by Q. There's like 8 pages of how I think about stuff and a bio there if you want to go back to the old January edition and read it. And then as far as Rails involvement goes, I was at least lucky enough to be the first change set in Rails, which I checked in as root, and it just says initial test. And the second change set was actually done by Jason. And that was just, as it says, the setup of the initial repository structure. And then since then, after sort of getting involved and doing some other things with my own company, Joyent, we started building a pretty large Rails application ourselves that is open source. The ability to run Rails applications is a desktop application called Slingshot. And then I wrote all the DTrace providers inside Ruby 1.8.5 and 1.8.6. And at least some of those ended up on Mac OS X Leopard now. And or is basically shipping with Solaris. Now, I thought I would talk actually a little bit what most of us are really concerned about, and that is scaling. And what are some terms around scaling? And what are some sort of special considerations for Ruby applications? Is this other mic on, too? Can you guys still hear me? Yeah, okay, so I don't have to stand there with that thing. So scaling for a lot of terms that you typically see is, we'll see words like scalability, throughput, performance. We'll talk about some basic limits of it, what the sort of rules of tens are. And at least for us that are writing web applications or any sort of application that talks over sort of an open protocol, we typically keep these types of web applications in their perfect permutation as being a stateless application. So we maintain state somewhere else, a data store of some kind. So scalability is not throughput. Throughput is, exactly as the word says, how quickly you can put something through a system. That's all. Scalability is also not performance. The performance of a language, how quickly it does a given function or not, has nothing to do with scalability either. And scalability is also not about language choice. So this conversation, at least in the Rails community, was pretty, was something we had to say sort of a lot in the beginning around the sort of Rails doesn't scale type of idea, in that scalability is taking something like an entire sort of application infrastructure that you have to do and realize that, out of, say, this list actually goes on, but it doesn't fit on the slide, that, out of 30 plus components that are required to, say, run and operate a quote unquote scalable application, 2 of these components are written in Rails, they're written in Ruby. The rest of them are a bunch of other stuff. Now, that doesn't mean that the performance of a language is not important. It is. And the performance of an application is also important. And how it utilizes hardware resources is also very important. But it doesn't impact scalability. So we'll see scalability is like just taking Legos and saying that, well, if I have 10 Legos and I stick 10 of them together, it's 10 times in size. That's a scalable system. And if I take 9 away, it's 1 in size. But the nature of the Lego itself and how quickly that Lego does something doesn't quite matter. So when we look at the performance of Ruby, and since a lot of us have Macs, you can go ahead and do something like use Ruby DTrace that's inside Leopard. And as you can see, basically as it says there, DTrace is a comprehensive dynamic tracing framework, as they like to say. But the basic idea behind it is that it's got enough hooks throughout the language that you can probe what an application is doing while it's running in production and hopefully not have an impact on it outside of noise. So it's not meant to be the same thing as basically trussing an application. Now, the typical types of probes that you see inside Ruby are things like function, entry, return, when garbage collection begins and ends, looking at a given line of code, when objects are created or started or freed, when exceptions are raised, when something's rescued, and then sort of a custom probe. And what you can do on a Mac at least is go ahead and even use instruments as an example where we see all the same sort of probes being inside of there in Ruby. And you can go ahead and fire up just a basic Rails application on your Mac and then go there and say, okay, dtrace -L, grep Ruby. And you can see all the sort of Ruby probes that are available inside of that system. That would be something like this. So the fact there's a mongrel running, and these are all the types of things that are available inside of there. We can see that the same things exist inside PHP and so on. And in fact, when you go through and you say, well, let's go ahead and write some very simple scripts in DTrace to sort of see how long, say, object creation occurs inside Ruby, then the typical sort of thing, as Brendan wrote here in a nice example that we wrote, a measured average of 677 nanoseconds is basically the object creation time inside a Ruby app. So for some things that Ruby does, like creating and destroying objects, it's exceptionally fast. It's one of the fastest things at doing that. And that's sort of a nice thing to see. Now, when you're exploring what DTrace is doing for you, in the case of a Ruby application, there's going to be just sort of 4 key areas you look for. One is going to be like odd, deep interactions with the system, meaning that you have a single Rails application or Ruby application that's running, and then you sort of say, well, let's just go ahead and look at, say, the system calls that it's doing. It's a real sort of simple thing. So one bug that we found inside Rails, for example, doing this with a certain Rails site, was that every time an exception was raised inside Rails, you would basically drill all the way down through the Ruby stack and back out again. So you'd be going through over 400 stack frames per exception, per error. The result of basically fixing that bug meant that an application with a reasonable amount of errors, not actually an unreasonable amount of errors, but something that's now doing, say, where you sort of see them come along in single-digit % of these exceptions being raised of some kind. That was doing things like adding 80% more CPU time and CPU load for that application just because it was drilling down through that. So, the fix is one goes to Rails and says, well, don't do that. You don't have to drill all the way down the stack inside Ruby and all the way back out again to make that kind of exception, or that sort of, well, all it basically produces is a page that says, hey, it's broken, and sends you an email. It's a bit silly. The other thing that you look for, and these are very sort of simple scripts to write, is variability in object creation times as being greater than, say, 10%. So what I tell people as they're sort of getting more experienced with DTrace, where you can write, say, 12 lines of, how quickly are my objects being created and then, say, destroyed. And you run that in your application when it doesn't have much traffic. You run it when it has a lot of traffic. You trace it at various sorts of time. You do it before and after deployments. And a typical trigger we like to use is say things like, when things are taking greater than 10% longer in creating them or getting rid of them, that raises a red flag. And you can probe object creation time. The other thing that comes out very often is you can take advantage of the thing in Ruby that you can in a lot of other languages that are, say, written in C. And that is just that you sort of go through and you say, well, what lines of code or what modules are using the most CPU time? And you sort based on CPU time as the application's running. And you can go through, like, for example, if you're using the pure Ruby-based MySQL connector or the pure Ruby-based Memcache client, then under load, you'll see these using, like 80% of the time the application spends on CPU is that module, the Memcache client, the MySQL client, or something you've written yourself that's in pure Ruby. And the nice thing about Ruby is that you can say, well, okay, so we need to actually write that as a C module inside Ruby. So now that functionality moves out from a pure Ruby to something written in C, to something that even breaks out of the Ruby interpreter itself, eventually becomes its own little C-based kind of app doing the functionality that you need. And you have that type of migration path available to you. And you identify those functions inside your application by saying, well, let me go ahead and see what things within my code is using the most CPU and track that over time. Also something you can do with Ruby DTrace. And then garbage collection ends up being one of the biggest problems that pop up in a lot of long-running Ruby applications. So you can probe whether things are being garbage collected or not, whether you should force them, whether you should use a different garbage collector, and so on. But if you decide that you're going to go onto your Mac as one of the great places to sort of start playing with Ruby DTrace, and then go to the DTrace toolkit, which is actually installed on there too, and has some basic sort of scripts around these to identify, it's going to be like these 4 things that you're going to look at for your application. Now, one thing that's become somewhat funny with Rails becoming popular is it's starting to be a valid question, what is Ruby? And in fact, the guys that run the Ruby project do a very poor job of release management, in my opinion. Meaning that currently right now in the case of, oh, that sentence isn't finished. Currently right now in the case of real Ruby, the C-based Ruby, there's actually 4 versions out in the wild of 1.8.6. So, and they're not called 1.8.6.1, 1.86. So there's actually one where 1.8.6, the real 1.8.6 is the Christmas edition. And then there became patch set 74, patch set 111, and then with a lot of the recent sort of security issues that came up, they said, well, go ahead and pick patch set 223 or 287 or 312 as one of those three that might work for you and not break your app. But they should be secure. So a lot of people, for example, bumped it up to like patch 222. So the problem is that very often, and you'll see this, like if you go to your Mac and write Ruby-V, it'll have some patch level number after it. Now, the funny thing about it, and I'll give you a great thing from having done the Ruby DTrace stuff, is that for Ruby 1.8.6, between all four of those patches, I had to rewrite the DTrace stuff, each single one. So the fact that a patch against 1.8.6 doesn't cleanly apply to 1.8.6 or 1.8.6 or 1.8.6 is poor release management, in my opinion. It gets even worse when you look, yeah.
There's another version on there now. There's this notion of what they call a passenger or something, or passage, where they have a re-entrant Ruby, and they essentially you personally enter Ruby code that can be used for multiple.
Yeah, I mean, the passenger stuff is the same guys that are doing quote-unquote mod Rails. So yeah, there's people out there that now have C-based Ruby that they say is an enterprise Ruby, which means that they're doing the patch management for you and renumbering the versions. So 1.8.6, patch level 111, the June edition, is, you know, passenger 2.1 or something like that, I forget. So,
okay, so now we have an intermediary company that says, we'll take care of it.
Yeah, so that's the thing. So the thing that you have to keep in mind with Ruby, especially if you're really hacking inside Ruby and really doing stuff with Ruby apps, is you cannot get away from having to operate your application, and you cannot get away from having to pay attention to the language. It's not as simple as just writing the Rails application a lot of the time. It gets worse when you look at Ruby 1.9 and Ruby 2, the development version. So Ruby 1.9 has been released, but what they basically did was backport so many of the new features from Ruby 2 into Ruby 1.8. Now that became Ruby 1.9, and there's not even a clean upgrade path from 1.8 to 1.9 because there's so many things that are different. So like, for example, when I was recently looking at 1.9 about how to port all the DTrace stuff into 1.9, there were entire files that weren't there anymore or integrated over here or that kind of thing. So again, going from 1.8.6 to 1.9, for somebody like myself who's modifying the Ruby code so that it can be instrumented, they had to write it 5 times to do that, even though it's only 2 versions.
Is it possible to port between various versions without any problem?
Maybe. Ruby runs Rails. Okay, 1.8.6 runs Rails. 1.9 runs the latest Rails. 1.8.5 runs some Rails with some patches applied to the Ruby. So real Ruby, C-based Ruby, still runs Rails. Maglev is basically now closer to a Smalltalk implementation of Ruby from the Gemstone guys. It does not run Rails yet. It does some Ruby stuff, and so on. Rubinius is now getting to the point where it does run Rails, but it runs Rails like 15 times slower than the real C-based Ruby does. So that's meant to now be closer to bootstrapping Ruby in Ruby, where the C-based core of Ruby has now been minimized to the point where eventually more and more of writing Ruby will be in Ruby. That doesn't currently quite run Rails yet. And actually, to be quite honest, in my opinion, and it's one of the greatest ironies, is that the best version of Ruby out there right now is actually JRuby. And I feel really bad for guys like Charles Nutter, because they love Ruby so much that they've gone out and helped write a spec for Ruby, because Ruby, by the way, doesn't have a spec. It's just a language that appears. There's no spec to it. So there's a spec that's been written for Ruby as a result of the JRuby and the Rubinius projects. JRuby, in a lot of cases, implements certain things in that spec better than real Ruby does and faster. It very reliably runs Rails. In fact, Rails inside something like Tomcat or Glassfish and half a gigabyte of RAM can do 1,500 requests per second on a Hello World application. And one mongrel running in 100 megs of RAM inside C-base Ruby can do maybe 100 requests per second. So even when you do the memory calculations that are required there, basically half a gig of JRuby can do, basically what 2 gigs of C-based Ruby can do in terms of throughput and performance. And JRuby's become pretty attractive, in my opinion, for some of our customers that are using it because JRuby opens up JDBC. It opens up a lot of sort of distributed object stores. It opens up a lot of the sort of interesting back-end type of things that one can do in other worlds that you can't do inside Ruby and you actually can't do inside Rails at all. One example would be things like database connection, pooling, and caching. Doesn't exist in Rails. And there's no middleware you can talk to have Rails do that. So if you would like to go ahead and run 4,000 Rails processes, then you better have database servers that can handle 4,000 connections from these 4,000 things, and it's quite inefficient as it gets bigger and bigger. So, and here's the other funny thing, not to go on about Ruby a lot, but since we're talking about a Ruby group, is that none of these are actually forks. So Ruby's never been forked. There's not a group that's come along and said, hey, you know what? I don't like the way that you guys are doing like the Ruby project. We're going to fork it. We're going to call it something else. No, there's actually been 3 entirely separate implementations of Ruby's syntax, a syntax that's only present in so-so documentation of the language itself and in the absence of a spec. So, yeah, well, I don't got to say too much more about that. Yeah.
Does it have a spec to the point where they have comprehensive?
No. JRuby's got almost comprehensive unit test suite. And the unit test suite for JRuby in terms of what Ruby should be, and Rubinius has done this as well, is like what Ruby should be. The unit testing for JRuby is larger than the unit tests that are available for C-based Ruby. It's just that these poor guys, they like Ruby so much they have to spend all day writing Java. Yeah, which is yeah. Yep.
So passenger also claims that it's 22% more efficient.
Oh, what's efficient mean?
Memory, in terms of memory.
Yeah. So
It's more than 5.
They forked, basically, and they have the intent on
forking it.
on giving back those changes.
Well,
Not accepted by the user.
they won't be. I mean, I've tried giving back the DTrace stuff all to the Ruby guys who develop on Solaris on boxes that Sun donated to them, and they won't take DTrace patches. So that is technically a fork, but real Ruby's at least open source and available to me. Maglev isn't, Rubinius is, JRuby is. I don't want to write things in now what's a proprietary fork of a language. Is it?
Yeah.
Yeah, just not, is that interesting to people? I mean, like, for me, 80 megs of memory versus 100 megs of memory, don't care.
Well, what they've done is they have this cat-bound write-friendly garbage collector. So it's actually just a little slower. It's not fast. And they put these
Yeah, that argues for the mess, doesn't it? So in my opinion, Ruby release management, a lot of the stuff that's out there is odd because there's currently multiple implementations of an unspec'd language syntax that's floating around, some better than others, and most of the release management around it's not very good. You think so?
Are they not doing it, or is the original Ruby people not accepting it?
Both. Depends. I'm just saying that, we end up running Rails apps where we have to do, say, what these passenger guys have done, where we end up with our own internal repository of Ruby, where things get fixed faster and are set up a certain way that just don't occur. And things that get pushed back, I mean, all you have to do is go and read the whole history of the recent security problem with Ruby and just see that these holes were identified on the mailing list 14 months ago. And it took a patch from Apple showing up to really sort of push it. So that's the state of Ruby, meaning good luck. Good luck. You still have to sort of tool around with the language. It's not done. And you can't always rely on even a version number. It's got to be a patch set. So scalability, then, to go back to that, is architectural. And in fact, that's probably one of my biggest beefs with even most sort of frameworks out there, whether it be a Rails or anything else like that, is that not enough of them out in the public space have architectural concepts or the idea that you have to operate an application or that it's supposed to be scalable sort of built into them from the beginning. So there isn't really the concept of architecture. There's the concept of writing, in the case of, say, Rails, a single application that 4 people are going to use using MySQL on a single little box. It's fine for that. So scale is relatively simple. You take a stack of 1 Legos, it's 1 Legos in size. You take 10 Legos, it's 10 Legos in size. That is purely the criteria for scale. And honestly, Rails in that sense is scalable. And as we'll talk about in a little bit, it's been, quote unquote, scalable since Mongrel was done. And it really wasn't necessarily until then. But we have to sort of qualify what we mean by scalability, because the load-based thing is honestly pretty easy for most people, like how to fix load-based scale. How do I take a lot more people and funnel them through an application? Is on a sort of specialized, all-in-house, people thinking about it is an approachable sort of problem. The geographic scale, where you're actually now sort of load balancing across sites, is another type of scale that's different from load-based scale and takes a different type of sort of thinking about it. And then the most common thing that I actually run across, especially for a lot of startups, is administrative scale. So meaning that you're going to have to actually scale a development team, scale operations, scale your data stores, scale your front end, write an application that doesn't inhibit that, and do it in a way that everybody buys into it. And quite honestly, when you sort of go through and you say, well, why is site X always down or slow or weird, or they died, or a bunch of people left them? Why did that sort of happen? It's not because they failed the load scale problem. It's not because they didn't geographically load balance it. It's very often because they failed at the administrative scale work of it. They're not doing proper release management. They're not testing anything. They're not actually sort of figuring out how this thing is going to operate and function. They're not necessarily sitting and thinking about how they're going to store data even. It's all going to be ad hoc and reactive when something bad goes wrong. So that's the typical type of scale that most people have problems with. So the general rules of scale right now, as a first one, is virtualization of some kind. And the only reason I suggest virtualization of some kind is because to this day, if you take something like Apache and put it on FreeBSD 4.9 on a Pentium 1.8 gigahertz chip with 2 gigs of RAM, that Apache will be faster in terms of requests per second than it is on a quad-core 16 gig of RAM box. It'll simply put out more requests per second inside of that. So the truth is that when you look at the way that an individual piece of hardware has scaled nowadays, and that what we call a server, is that a lot of software that's still available to it is not written to take advantage of that. So very often with virtualization, you sort of say, well, oddly enough, if I take 16 gigs of RAM and 8 CPUs, and I divide it into 16 virtual machines with 16 Apache instances, I get more out of that than I would with one Apache instance running in one machine with 8 cores and 16 gigs of RAM. So virtualization of some type, or just keeping your components small, is important. The guys that are building things like, the big sort of larger cell machines at IBM are taking this on a hardware level, where you have a blade that's got 16 little servers inside of it that are that big. 2 gigs of RAM, one little CPU, 1, 2, 3, 4, 5, 6, and that's how a blade sort of fits in. So, of course, we separate hardware components. You try to keep it simple. So if you're building your own stuff, pick a chip, pick a type of RAM, pick a type of box, pick a type of switch, pick a type of cable. Things should basically add up, and that's sort of a constant question you should be asking yourself. That if traffic's coming in here and going out the back, and it's 100 in the front, it should be 100 in the back. Real simple. It should always be sort of something like that. You will end up sort of having to manage configurations. You will have to sort of do distributed control of things as you're sort of scaling up. You should constantly be sort of thinking about a concept really maybe, well, a bit more from like combinatorial chemistry, if you will, but how am I going to consistently pool and split my architecture? What services can be pooled together, both logically or physically? What things should be split? I should always pool and split. And basically sit down and understand what each sort of component can do as a maximum. And I'll give you just a perfect example of this for when you want to right size an application. So if you sit and you take, for example, again, just like a little 2 gigabyte server with a CPU in it, just a standard sort of 3 gigahertz old CPU. And you take Lighty, and you tell Lighty, fire up 10 fast CGIs for Ruby and connect to the database. And then all of a sudden you do that and you say, well, we're getting like 240 requests per second into that Lighty, and the app isn't working anymore. The response times are junk. But then on the very same exact web server, if I sit there and say, well, can it serve up a static file? No problem. Can it still serve up a static file very quickly, even though it's quote-unquote under load? No problem. So Lighty, 10 fast CGIs that are, say, running Ruby behind them, or Mongrels, proxy them however you want. You say, well, that can still do 2,000 requests per second of a static file, while it cannot do 200 requests per second of a Rails app. Yeah? Lighty, L-I-G-H-T-T-P-D. It's a little web server. Little web server. Pick a web server. Lighty, Nginx, Apache, whatever you want. So you can sit there and say, well, I'm not getting the throughput I would expect, but the server seems to be working fine because it still serves up a static file just fine. I can access the database fine. Doesn't look particularly overloaded. And then you start drilling through and you realize that, well, inside this stack, there's a module interface for interacting with the fast CGI module. And guess what? That interface can only do 200 requests per second. So that becomes the fundamental bottleneck inside that stack. It determines how many of those that you run. You see this all the time if you decide, well, I'm going to take Ruby. I'm going to fire up 20 mongrels. I'm going to fire up Apache and put 20 mongrels inside the virtual host for this. And then all of a sudden, you're doing 180 requests per second on that Apache. On other virtual hosts that still say serving static files very quickly, no problem. Yet for some reason, you can't get more than 150 requests per second to this back-end Rails application. Yet you hit each one of these 20 mongrels, and each one's doing 50 each. So it should be 50 times 20. You should get 1,000 requests per second out of this, but you're getting 150. And it's because you start digging in and you realize that the mod proxy balancer inside Apache is a fully blocking module. It is capable of doing 150 requests per second, period. So that becomes then the fundamental limit in your stack. So as you sort of drill through, you say, what are each components and what are their interfaces? What are they capable of doing? And every single interface as you drill down, what are they capable of doing? And what that basically means is that when people say things like, well, but I can run 20 mongrels on this piece of hardware, and they can do 50 requests per second each, and 20 times 50 is 1,000. Well, how can I have them all doing it when only 3 fit behind an Apache? And I said, well, you got to run 7 Apaches too. How do I run 7 Apaches? Exactly. Now you need a load balancer. What's a load balancer? And then it just keeps on sort of moving up. And then you say, well, why do you have Apache there at all? Well, to proxy to all these things. Well, it's not all, it's 3 of them. So it's really sort of starting at the front and saying, what's every sort of thing capable of doing as a component and as an interface between components? That's a general sort of rule. Virtualize, virtualize, virtualize. Keep things simple. That's the KISS. Things should add up. You want to basically pool and split. You really want to sort of understand what your components do and break them out that way. Yep.
From my experience, it seems like us adding extra layers doesn't even necessarily slow it down, because I've got a lot better results out of thin than out of mongrel, even though thin has the rack, which is not there between mongrel and the outside. So even though you're getting 2 layers, it still seems to be serving up faster.
Yeah, so as an individual thing, but if you convert from mongrel to thin, and you're running 180 requests per second, and you're behind Apache, you cannot do it. So the speed of thin versus mongrel actually does not matter, because that's not the limiting factor. So, like for example, the better way of doing it, as I'm going to say, is that if you have something like a web server in front of your Ruby app to serve static files, then static files should always come from static.app.com or something, because eventually they're supposed to come off of a content delivery network. And that's supposed to be coming from application servers. So I'll typically do things like run 4,000 mongrels or say 4,000 thins, and they sit right behind hardware load balancers. And that's all they do, is that. There's no layers in between, nothing funny. You're keeping it simple. You're keeping your layers as low as you can, and you're just doing it that way. Now, there are fundamental limits to scale. First one's money. Second one's time, because if you have a lot of money and a lot of time, you can scale anything. If you have people that can do it with the right experience, you can scale anything. If you can power it, you can scale it. If you can serve it, bandwidth-wise, you can scale it. So the fundamental limits to how you can sort of scale an app out there right now is, again, not language choice, not a bunch of other stuff, but fundamentally it's how much money do you have, how much time do you have the right people, and if you're compensating by putting a lot of hardware behind it, do you have the power to power that hardware? And it's a lot. There's stories of Google running 100 megawatt data centers, right? Big data centers. Yeah, maybe, who knows? It's ND8 or something. But big 100 megawatt data centers down by the river. Now, 100 doesn't sound like a very big number, because it's 100 mega, so it's 100 million watts, which is a big number. And 100 megawatts is like what Seattle uses for power. 100 megawatts is actually, when you look at active power, 100 megawatts is, I think, yeah, almost 25 megawatts more than what a tier 1 network like level 3 has across 80 facilities. Right? So it's a lot in a given spot. So let's power 200,000 things to scale our stuff. Can we do that? So you can do some very sort of simple math, and it's always a great thing to do, because a pretty common sort of question I get is, you know, hey, I'm doing application Y. It's going to be huge. It's going to have 1 million people using it tomorrow, 10 million people using it in a week, all of America using it in 2 months, and there will be 1 billion people on my application by 2009. how much bandwidth is that going to use? So, you can do some very simple math and say, well, usually nowadays when I'm pulling up a page, a small page nowadays, a small page is 120 kilobytes, like Facebook app small page. The average page now, they said, is weighing in at like a meg. So if you do a 120 kilobyte page with, say, 20 objects, so there's like 19 images in the thing coming up itself, and you just pick sort of a request per second constant, then the math you do, the 8.6 comes from 86,400 seconds, is that you're going to do 8.6 million page views per day. So the general sort of rule of thumb is that for 100 megawatts of bandwidth, you will do between 5 and 10 million daily page views. So 100 megawatts of bandwidth is what things like a 300 million page view per month WordPress.com a year ago did for the pages themselves, not, say, static assets. So you can pretty reliably say that, well, for most of that stuff, 100 megabits per second is going to give me 5 to 10 million daily page views. Now that's a nice thing because from daily page views that becomes CPMs and however else you're thinking about sort of monetizing your business. And it's amazing when a lot of times you look, you say, well, this site is, say, very popular, and they say that a lot of people do it, and a lot of people go and talk to each other on it, do a lot of great things, and then you look and they're doing 40 megabits per second of traffic at peak. And it's because, well, having a site that's doing 300 million page views per month is in fact like a top 200 web property. So that's the sort of general limit for bandwidth. If you want to do 10 million page views, you're going to buy 1 to 200 megabits of bandwidth. 200 kilowatts nowadays is going to give you about 400 servers. I picked 200 kilowatts because if you go down somewhere and say, I want an office here, and downstairs it's dry, let's put a data center downstairs. And you call up the building and the utility and say, I want to power a data center downstairs. At the most, they'll give you 200 kilowatts of sort of industrial power in a site. That's about 400 servers somewhere. And you see as sort of general rules that come out of this again, two that I mentioned earlier, is sort of the rule of 10. And that is that it's always nice to sort of sit down and say, I'm going to tier out my app. There actually is going to be sort of a front, like say Apache in front of a Mongrels or something like that. Tiers are functionally different, and I always say that tiers should be 10x different in throughput or better, but at a minimum. Now, if you could only put, say, 2 app servers in front of 1 database server, there's something wrong. So when you decide that you're going to put like a caching infrastructure in front of your app, then one caching server should push out the same throughput of at least 10 of those app servers. Otherwise, you have work to do on this thing you call caching. Cost, generally, for a freestanding application very often ends up being less than 10% of revenue. You look at things like the capital expenditures on quote-unquote infrastructure of, say, an eBay, it's something like 6.5%. You look at, say, what Google says their CapEx expenditure on data centers and infrastructure minus people is, it's like 8%. So time and time again, you look at, say, even large web properties or smaller web properties, and you say, well, it's going to make, quote unquote, this much in revenue or take this much in financing, if you now think of, say, raising VC as revenue on your balance sheet or money of some kind. Well, if you got $1 million in the bank over a year, then you should really sit and say that all the infrastructure to put that together should be less than 100K. And that's something you see time and time and time again in capacity planning. Now, there's some fundamental ways to scale as well. And it's basically just vertical or horizontal. And there's a lot of noise made about this, for example, of one should always horizontally scale your applications. One should always get rid of all vertical scale that you possibly can. But you actually can't. Because the fundamental distinction between these things is that things that maintain state have to be vertically scaled, and things that are stateless have to be horizontally scaled. Fundamental rules you can't ever get away from. So let me tell you like what state is. State would be like /home. So I'm going to have storage, and everything's going to live under /home. Single namespace, /home, under a given host name, and then everything underneath there has got state. Things inside databases, state. An IP address, state. Right? Now, when you think about how do I take something that is normally vertically scaled, like a file system, and make it so that I can horizontally scale it, fundamentally what occurs? Fundamentally, you remove state and you put it somewhere else. You can't ever get rid of it because otherwise you wouldn't know where anything is. So like for example, let's take a real simple thing out there in the open source world like Mogul FS. So the idea that I'm just going to go ahead and store files all over the place on a bunch of disparate storage, and then they're going to get served up. Well, where all of those things are is tracked in a MySQL database. How to find all of them comes out of a MySQL database. So you've taken the idea of state, like a host name and a path, and you've put that into a single spot over here, and that allows you to horizontally scale this other aspect of it. You have the same thing every time you want to build a large cluster file system. So that all of a sudden when you're doing things like Lustre, you say, what are these dual metadata servers that are so important? Well, it's because instead of doing like on a Mac where you have a file and then a .file name that contains all the metadata for that file, we say if we yank all the metadata out of file systems and store them in one spot, then I can horizontally scale all these files out however I want. But you can never get away from vertically scaling that metadata servers. So time and time again, you see things where it's like, you know, when we used to do, say, big petabyte, petabyte used to be really big, like 2001, 2002 type of stuff. And it's like, oh my God, we can't back up the metadata servers within 24 hours. What are we going to do? We start getting storage where everything's on non-volatile RAM. You get RAM SANs. That's what the metadata servers become. $10,000 a gig. Because you can't ever get away from vertically scaling certain things. So when you do that, you say, well, what's got state, what doesn't have state? And sort of acknowledge the fact that you're always going to have to horizontally scale some things if you're lucky. You're always going to have to vertically scale the things that have state. And whenever you have a problem vertically scaling it, you try to take as much data out of that possible by taking the things away and separating the state from the actual stuff. Vertical, of course, means more stuff in a box, which means buying bigger and bigger boxes, which is why IBM can still sell large mainframes and why Sun can still sell Sunfires. And then horizontal's got something that's somewhat a bit more interesting, and that is that all of a sudden in things that are horizontally scaled above a certain size, then a whole different thing comes into play that you haven't seen before. And that is because in a vertically scaled system, it's all about like bus speed and components talking to each other as quickly as possible. On a horizontally scalable system that's also economic, it all becomes about the network. So if you have to do things like move things around at very low latency and with very sort of high throughputs, then the network becomes the bottleneck for you, not the sort of nodes that you're doing. So what that actually means, as we're going to see in a sec, is like in the case of web applications are stateless. Every time you basically write a Ruby app or a Rails app, is that the worst thing you can ever do is do things like store sessions on disk, these session files. They used to be the default for Rails, that it wrote all sessions to temp. And that used to be the case for a bunch of stuff. And then you have to go through load balancers that have sticky sessions, quote unquote. And then the big thing with Rails 2.0 that came out was, well, all session data is now in a cookie. So we've taken that and pushed it down to cookies. And people are maintaining their own state information. And now we've actually made our Rails application stateless. So it should be a piece of cake to scale at that point. And that's always the sort of idea. Stateless apps are easy to scale, and they are. But the problem, though, is that the front has state. Meaning, how do you sort of scale when you have to connect to an IP address? So you go to your computer and you type hostgoogle.com and 3 IP addresses come out. But that's probably not 3 IP addresses on 3 servers in the world, right? So how do we take something like a small set of IP addresses and address them to a lot of sort of things in the back end. The application, of course, doesn't have state, but all sort of data stores have state, and there's a big question around how to scale files, databases, and everything else. And that becomes the typical problem that I see time and time again, especially in sort of the Rails world, is the web development's not networking, and web development's not data management. And as you're starting to build more and more sort of external web service applications, and that would even be something like a Facebook application that feeds into Facebook, then it turns out that the network is number one. How quickly things can talk to each other becomes the limiting factor. And you see this even in things that you're doing, like let's go ahead and do a measurement like I'm going to take a server that's a MySQL master server, and then I'm going to make another MySQL master, and then another master, and then another master, and I'm going to make each one of these the master and slave of the other until I close that into a chain of masters. And then you ask yourself, well, on a gigabit network, how large can that circle get before I make an update to number one and go all the way around the ring, and the replication speed is slower than the insert or whatever change your occurring is. And on a gig network, it's about 16 nodes. So whoop, gets to about a ring that big, that's it. So the network becomes limiting at that point. The network happens to not be free, of course, especially if you're talking between stuff. You know, so time and time again, it's sort of funny because, you know, we've had, like in the case of, say, a lot of social networking apps that we did around open social apps and Facebook apps, where until we set up peered connections with some of these other providers, you know, a guy would have a Facebook app go from no users to 10 million users in 90 days, and it'd be like, hey, you're pushing 1.5 gigabits per second to Facebook all the time. And they're like, that's awesome, that's awesome. And you say, that's $112,000, please. Huh? yeah, you're little stealing panties from each other and putting them on the little image head. That's $112,000 of bandwidth. Oh. Oops. Monetize. Yeah, well, you guys don't even, it's amazing. I should have built a Facebook app. I know that sounds funny, but our guys at, some of these Facebook apps do so many page views. They're doing $3 to $10 million a year in like ad stuff just based on the CPMs that they have, and it's 2 guys working in a garage. Nuts. Could have been me. All I had to do was come up with something. I poke you. So I would have been more clever, though. I would have done stuff like, if I was going to go through and steal panties or give panties as gifts, I'd call them like Victoria's Secret Wonder Bra something, and then 10 million users later call Victoria's Secret and say, that'll be $2 million, please. So what are the common problems for all Ruby applications? Turns out to be very little things with Ruby. There's certain Ruby and certain Rails applications that I've seen where they've managed to do all of these things wrong. So let's go ahead and pick an application server that's a bit crappy. Let's do something like take the number of objects served per page, like a great idea. Like, I never would think that somebody would have 8,000 friends. But the original sort of design is to show 8,000 avatars on your page. So lo and behold, every time somebody loads that page, and if they're loading it a lot because they're curious what's going on in their life, that's 8,000 requests every time you click the reload button. Or better yet, you've put a JavaScript inside that page that forces it to reload every 2 seconds because you want it to be real time. So it's a bad idea to serve 10,000 images on a page. I mean, there's a reason why you can only have 5,000 Facebook friends. There's a reason why when you used to belong to like the UCLA network, you belong to the UCLA network. You didn't belong to other people. It's because they used artificial or sort of social limits to limit how many things they have to deal with. You know, it's the same thing with something like Warcraft. 5,000 people on a server, and servers are in battle groups. So let's take the game and make the game sort of reflect a certain thing, but what that certain thing is, we're only going to be able to scale to this point. So battle groups will be 20 servers, and servers will be 5,000 people each. That's it. It helps the game. But it's really about how many objects you're serving in a given spot. Application switching becomes actually incredibly important, meaning how do I present 1, 2, 3, 4 IP addresses to a whole lot of backends? Static file serving becomes important because like a Rails application should never do it. People consistently have problems with uploading and how one sort of stores files and data. The little sort of story about this was, again, there was one site I remember dealing with where they were loading up all these images like per page. And then you fix that, so you paginate them, so maybe a couple hundred come up. But then every time one would do, say, a snapshot at night to sort of back this up, and this is like a real-time snapshot on a copy on write file system, the site would pause for half an hour. That's not supposed to happen unless there's some weird bug in a NetApp or something like that. So it's like, well, let's take you off of this sort of file system. We'll put you on Waffle and NetApps and big fat NetApp and do that kind of thing because no one can ever complain about the performance of a NetApp. And you start copying all the sort of stuff over, and all of a sudden, a few hours later, NetApp throws this big error saying you cannot have more than 100,000 directories in a directory. That's the hard limit Waffle set because they don't want you to ever slow it down. So it's like, what? How do we hit that error? Do an ls of home/app/public/images, please. And a day and a half later, that ls finished. And there was 1.5 million directories in it with one image each. And out of that 1.5 million directories, 1.2 million of them were some variation of the word test. And then it's like, why do you have 1.2 million directories with the word test somewhere in the name? Like a weird MD5 hash with test and then like 001 at the end? Why are you randomizing strings around the word test? And it's like, well, yeah, after the first time we did a deployment, the unit tests started failing, so I just sort of randomized the name around the directory. So I'll run test, and it'll just do, and it's like, well, when you make a test directory, do you get rid of the test directory? That's a great idea. Okay, I got you. So you generated from unit test 1.2 million directories in a single directory, and that's what's making your application exceedingly slow. And not capable of being on $1 million piece of storage. And you can't do anything. So storing files and data, they don't go in home/app/images. Should never test your application. Not on production infrastructure. Not on production infrastructure. So your application servers right now is, for Rails and Ruby, something like Mongrel. There's other stuff out there, Mod Rails, Thin being sort of a event-based type of Mongrel. It's fine. Mongrel happens to be good enough for most stuff. JRuby plus your preferred app server, stuff like Apache PHP. These are real sort of simple types of app servers. Now, in the case of Ruby, when Mongrel came along, Mongrel actually, in fact, saved Rails and saved Rails deployments because it went ahead and made an explicit choice for the Ruby community. See, the way that you typically do these things is, you can take something like, not everybody can see the board, but you can take something like Java and say, I'm going to have something like the JVM, and then I'm going to have all these things that I'm going to call now threads within them, and they're all going to sort of have this shared heap. So that's heap, and that's a VM. And these are quote unquote threads. Now, initially the JVM said, I'm going to manage threads. And then they said, well, that's actually a bad idea. That in fact there's this operating system that lives above it that's actually pretty good. So why don't you make these threads kernel threads, and then we'll all be okay. And then you have now a VM like, say, Erlang, where you have real sort of things that aren't threads, but they're real sort of lightweight processes. They don't have a shared heap. Each one has their own heap like that. And that's sort of the next step up. And then what does Erlang do? Erlang basically fundamentally does process management. And it's exceptionally good at it. Because this language is sometimes meant to be put on metal or a real minimalist OS. They didn't do good process management. Now, it's funny because a lot of people are like, Ruby needs to do threads. Ruby needs to have this or have that or do this kind of thing. The VM needs to be better or worse or anything like that. And they ended up in some weird amalgamation inside the middle. When really what you want is you basically want an operating system doing process management. And you want now not lightweight processes, not threads. You want real processes, each one with their own sort of shared heap. And go ahead and let the thing called the operating system, which is, in the case of, say, Unix, been evolving for a long time around process management. So Mongrel basically said, and you have the same concept between, say, Apache and FastCGI and processes, right? Where in the case of that, you know, what was something like Apache supposed to be? Apache was supposed to be this big thing here that used a FastCGI interface to sort of take persistent processes within. Each one of them ends up sort of sharing memory and some sort of bits, but each one is fundamentally now a process being managed by Apache, and Apache is sort of being managed by the OS. And you got some sort of oddities, like is the module interface limiting, or where is a problem sort of occurring? So Mongrel said, let's take a Ruby process and minimalize it down to something very small, and we are going to explicitly say that this Ruby process will speak HTTP. That's it. So do that. You take a single process, its own heap, and you let great operating systems with a great process management manage them. And that's all. And in the case of, say, Mongrel, is, you know, and variations that came after that, it said, now let's go from this whole idea that the Ruby VM even matters to the fact that maybe it doesn't matter, that all the Ruby VM now becomes is something that's managing the size of heap and what that interpreter's doing. But it's a process being nestled within an OS and regulated that way. And that really sort of simplified the model for Ruby applications. And a lot of the times when you hear people talk about the way the VM should or shouldn't be designed, the way the interpreter should behave, the way app servers should behave, they're trying to sort of not take one stand or the other. You have to pick the way the JVM's done it for a reason, the way Erlang's done it for the reason, the way Mongrel has sort of implemented Ruby apps for a reason. That these are, in fact, quantums. 1, 2, 3. Let's not do things in between. And a lot of the stuff is, in fact, in between. So mod Rails, for example, is an in-between. Let's complicate the stack even more. Let's add in something now called Apache that's managing processes and other stuff. And there's more interfaces and more components, when in fact it should be nice and simple. So that's why Mongrel was nice and simple. The stuff on a page is sort of funny when you look. Stuff on a page is something like TechCrunch, for example, is the prototypical modern web page, 1.42 megabytes in size, 125 objects per page as it sort of serves up. And JavaScript fakes a whole bunch of stuff, and by the time it's done faking it, it takes 32 seconds for that page to come up once everything's all been faked. Some things seem snappy, but they're not. Facebook, 105 requests, 260 kilobytes. The interface is minimalist for a reason, because they want it to come up in 10 seconds now. Yahoo does a better job, 42 requests, 209 kilobytes, 5 seconds. Google News pushes it down to 51, keeps the request small as possible. So you want to sort of minimize all the stuff that pops up on a page as far as objects go. You want to decide at some point that if you're going to have to switch more than 100 megabits per second of traffic, you do actually have to buy hardware that does that for you. So the best thing for Ruby applications and Mongrel applications, you get to a given point, is you buy a big IP. That's in fact the best thing at it. The reason it's really great, and this isn't an F5 pitch or anything, is that you can actually, it's one of the few hardware load balancers you can buy where you can pack in like 10,000 backends. Things like the Juniper load balancers that you buy that integrate into switches are limited to 64 backends on a configuration file. NetScalers don't scale to a lot of disparate backends like that. In the case of Rails applications that are doing 1 request per second each, and you need to do 5,000, you got to run 5,000 of them to do that, to sort of compensate for it. You know, full sort of load balancing, and then great test. So this, for example, is saying if a mongrel ever gives me a 500 error, redirect the traffic to another mongrel and don't ever talk to that one again, so that you get rid of all those types of, you know, problems inside of them. And then as we're going to see, if you're not quite able to do fancier stuff, you can go layer 7 sorts of things. So the idea being that layer 7 says anything that comes after the URI, a /login, a /calendar, a /list, a /mail, that traffic direction can occur to different servers depending on what comes after the URI. To solve the how many things am I serving per page, you use things like asset1.joyent.com, asset2.joyent.com, asset4.joyent.com. And you take that infrastructure and you serve it separately. And when it comes to sort of storing files, you know, Jameis from 37 Signals a couple of years ago wrote a real great sort of thing. He calls it ID partitioning for some reason, but it's a hashed directory structure. And it's saying that, well, the file system they're using, you can only put 32,000 files in a given directory. So even though you're storing stuff, you have to basically space them out. And it's a very sort of old solved problem. Let's take the path name and make it something that's sort of logical. We'll store it in a database, and we'll come up with rules around there. And what's funny is that people even still talk about the sort of web app database type of structure anymore, when in fact, the sort of web app database type of structure has been dead for a long time. In that what you generally make is you make load balancers, caching of some kind, application, caching of some kind, data. And then you silo these off as different services, and you just sort of repeat them like that. Where you stick the cache depends. In the case of some load balancers, there's a cache at the back of it. In the case of some applications, they cache some data. In the case of some applications interacting with the cache is with the app, or the cache is, say, a memcache type of cache, or it's a cache that sits in between the app and the database, or it sits in the database. So meaning that load balancers, application data, and then caching layers in between, where you're sort of building the cache fluctuates from, say, load balancer to its own entity to the front of the app, to back of the app, its own entity, front of the sort of data store. And you sort of have all these caches you worry about. Yep?
If you were designing something up front, if you were to access some data, now you can put it in files, or alternatively, you can use perhaps a database to access the information in assembly.
Yeah.
I'm sort of guessing that a database would be faster than the parser.
Depends.
Along there?
Depends. It entirely depends. And that's the problem, is that people don't talk about the depends enough. And the depends aren't accounted for by frameworks. Meaning that, and I'll give you some examples of this. Meaning that very often, if you're doing a very sort of simple query with a Rails application against MySQL, MySQL will be faster at doing that than accessing that data as a small array out of memcache. So if you're writing a little Rails app and you got MySQL and you throw memcache in just to see how things are going, you're sort of developing and testing, accessing the database directly will be faster for most stuff. But now if what you have is, say, 2,000 friends that need to live in a sort of predetermined array of some kind, and you want to cache it, and you now have a lot of people using it, and pulling that out of a cache is faster. So it depends. Sometimes sticking things in 1 terabyte size binary files that you sort of rearrange in, and you put an index on the top, and you occasionally vacuum them, and you sit them down, and you do various sorts of things is faster than accessing a relational database. So what doesn't occur, and we'll sort of see this in a bit, is that there isn't very often discussion of what type of data do I have, where should I put it, how should I serve it, and how quickly does it need to be served? Is it really has to have 100 millisecond latency or not? And that sort of thing's not baked into, say, frameworks. I can't go through say, my Rails app and say, oh, this data here, if this object's created, it's very important. I want it done 4 times across 4 physically distinct things. Here's the IDs for the 4 physically distinct things. And if somebody generates it, they need to see it immediately. If somebody who's never been to the site wants to see this content, they need to see it immediately. But their friends can see it within 10 minutes, and their friends can get an email about it within an hour. And then I'm going to put all the metrics in place so that I can make sure these things are occurring 99.9% of the time. Like that thing, not baked into Rails or anything or Ruby or nothing, right? So there's also the concept now for a lot of stuff of caching up, meaning like in the case of, say, Facebook applications, you can preload all this stuff into, say, a social networking app and then write something in Tickle, TCL inside, say, a load balancer, and say, hey, if they're asking for this URI, just serve it yourself. Yeah.
It's hard to be that. In some cases, you could actually do it, say, Ruby, in which case you're talking about a couple hundred accesses per second. Yeah. Unless, of course, you were using the JRuby version, which may get up to, say, 1,500 accesses per second.
Yeah.
Alternatively, if you actually pre-created the file as sort of static, most of the time, then you get it through Apache, which is how many per second?
It depends.
Yeah,
No, you can. I mean, you can tune most static web servers to do like on the order of 10,000 per second for a static file. Let's say less than 20 kilobytes. So yeah, absolutely. But those things aren't explicitly baked in.
One last thing. Why is JRuby faster?
I don't know, actually. And I'm not so sure that it is always faster, depending on what you're doing. For a Hello World application, JRuby and most app servers is faster than most C-based Ruby app servers. So tiers and silos is typically the thing that you basically sort of structure it out. And you pay attention, as we said earlier, to all the sort of connections in between. A tiered and silo application is to say that, well, I'm going to make DNS entries in. I'm going to have things like static.domain.com, dynamic.domain.com, and I'm going to sit down and decide that I'm going to silo out my data depending on what's important. You already do this if you're like storing files differently from a database without necessarily thinking about it. You actually have a static file silo and like a database silo. But what you end up doing, for example, very often is people will say things like, oh, you know what? Actually, our user database now is so big, it shouldn't be with all the data. Let's break it out to its own database. You've siloed it now. It's on its own sort of thing. You've made a service out of it. So that when you sit down and say from the very beginning, I'm going to write a Ruby on Rails application that's sort of scalable, then I'm going to make sure that I at least have sort of a domain.com as an explicit idea. That from the very beginning, I'm going to decide that I'm going to write asset.something.com as sort of a static silo that all statics go through. I'm going to sit down and decide that uploads have to be authenticated. I'm going to break out an authentication system. I'm going to break out the uploading. Eventually, I'm going to write my own uploading and queuing application that takes care of it, that's not responsible for page load time. I'm going to take downloads. Some downloads have to be authenticated, some don't. I'm going to go ahead and say that I'm going to administer things. And administration needs to fundamentally be, eventually, sometimes its own app. So a lot of times you sit down and you say, well, from the very beginning, it could be like one app. It could be one little Rails app, Ruby app you're writing. But there will be the idea that there's the main app itself. There's static assets on that page. There's things that might be uploaded. There's things that might be downloaded. And the app might have to be administered. And from the very beginning, those are at least different DNS entries. And they can eventually sort of become their own sorts of other things. Yep.
Some applications will, when you register for the thing, you get your name.application.com. Is there any way to silo that in a reasonable way? A lot of times DNS just needs to all
Either, so there's a, so I'll give you I'll give you a great way to do that as we go. I don't have it, but so let's say, for example, that it becomes jason.myapp.com, william.myapp.com. So there's a few ways of doing that. One is that, of course, a wildcard doesn't fly because you can't wildcard. That defeats the purpose. So jason.app.com and william.app.com has to have their own A records going to an IP address that may or may not be different. Well, but there's two ways of doing it with a DNS service. So one way is like the idea that I'm going to have a zone file, like a single zone, that contains maybe 1 million different A records inside of it, which becomes impossible to update within a reasonable amount of time. So what you do is you end up writing zone files or zones in a database, even for like a DNS-based system, where each one is treated as if it's its own domain name. So instead of having like zone for domain.com and then having an entry for jason.domain.com, william.domain.com, everything else, it's zone jasondomain.com, zone william.domain.com, zone domain.com, zone wildcard, and so on like that. So that each individual entry, as you move down the sort of fully qualified domain name chain, becomes their own zone entry, not their own entry in a zone. And that is a scalable way of doing it. So, as I was saying earlier, just on the last sort of two problems, is for the administrative scale, this is where teams building any kind of app fail, when a lot of the sort of app stuff comes out bad. So the thing just to keep in mind is that administrative scale, business scale, team scale is in fact a valid type of scale to think about. That the way that you're going to operate an application has to be a consideration. And there actually has to be things, and it seems funny sometimes if you're in a very structured development environment, there actually has to be things like release engineering and rollback plans and maintenance that's scheduled. So you have to be proactive, not reactive, and it becomes a very much a sort of cultural thing. And time again, it's like I sit there and you sit there with like, you know, a customer or somebody else, and you're like, these guys are having a real problem scaling. None of it turns out to be technological or technical. It all ends up being things like, oh, the ops guy and the lead developer, they hate each other. And the data problem's actually not even remotely solved. So, meaning, you know, how do I, from the very beginning, have an application or a framework where I can make decisions about how the data is stored, how it should be served, how it should be replicated or not, and what the sort of requisite backends for those things would be, how I can make sort of different choices between them, and how those backends can scale for applications. How can I have a backend that scales a lot for writes, one that scales a lot for reads, one that stores objects that are pre-compiled, ones that do not, things that are object-based, things that are relational, things that are on disk, things that are in memory. How do I sit there and start tiering and siloing out my data beyond just that should be a file, that should be in a database type of idea. But there really is no real solutions for that. It's not baked into languages like Ruby, and it shouldn't be, but it's also not really existent in most frameworks now. And if anything ends up being sort of the next big frontier, if you will, in terms of what sort of solves scale, is give me a great either multi-purpose or multi-siloed data store as backends that I can write a normal web application to, and I can go from 1 user to 1 billion users, and 1 site to 20 sites, and 1 continent to 4 continents without a rewrite. And nothing exists that allows you to do that. And that's it. Thanks, everybody.
If we have any other questions, if people would like to come up to the mic, then that way you'll get on the video.
Get on the video. Nice.
So does anybody have any other questions at this point? Okay, so I guess now we're going to head downstairs and try to get some food.
You have a question?
Hopefully.
You can.
All right.
You can also say the question. I can repeat it. Oh, was that repeat questions on the back for me?
Yeah, and actually, one other thing I want to throw in, Ola Bini actually came here and gave a talk on JRuby, and it's on YouTube. And he actually has a pretty good book called Practical JRuby on Rails that is you should read.
Yep.
Great. So there's an awful lot of information. Great talk. I'm just wondering, for those of us who didn't quite catch all of it, and just for future reference, can you recommend any articles or books or sites?
Well, so yeah, if there's anything that becomes, most people refer to either Theo's book, Scalable Internet Architectures, or Cal's book.
Okay.
And I guess I'm going to say it'll be a public video. I mean, Cal's book is, it's okay. I mean, it's mainly like how do you use MySQL and do replication and that kind of stuff. Theo's book is at least a bit more, how do you sort of sit down and think about architecture? And quite honestly, that's really the only book that's sort of out there.
Okay.
There's a few good articles as well. They're pretty much all in Usenix presentations, which is probably one of the more interesting things to me about computer science is that conference proceedings is still a valid place to publish things. Mm-hmm. It's not like that in other sciences anymore. There's a few, but not too many. Yeah.
The second question I have is just the last thing you said seemed a bit surprising because it seems like there are some things to help you with scaling your app massively, right? There's, Joyent offers some things. You've got Amazon Web Services, and now you've got Google App Engine. I mean, what's sort of missing from these?
What's missing is that all of those things, and we're a perfect example of that, is that fundamentally we end up having to scale MySQL for people in, say, some cases. So the real question is, why are they using that in the first place? And it's because of ease of access, not because it was the best choice. And Google App Engine's great as well, and Bigtable's great. It's great for reads. I mean, so you have a thing where I can read stuff really fast, but what if what I'm doing now is something that's really closer to like a real-time gaming application, and 50 to 60% of what I'm doing is a lot of really small writes? That's in fact a different type of thing than a very fast read sort of data store. And the thing time and time again is I would just love it so that if 5, 10 years from now we would all look and ideally things would be advanced in our field. And an advancement for me would be that architecture and operations becomes baked as sort of the default way that frameworks operate. That the default right now for Rails is to say use like MySQL, and that's all. That's it. So it's great for an app that 4 people will use. But to go beyond that means doing things very often like, it's funny when you say, okay, so we wrote a Rails app, now let's break it out and write them as a custom mongrel handler, and then let's take that custom mongrel handler and push it down to even another thing that's a C extension to end up being its own little C app doing it. Well, is that really the sort of framework progression that a Rails app should go? Should it really go from a Rails app to a custom mongrel handler to a C extension to an app in C? Maybe. You know what I mean? It's that sort of thing's not quite baked in. And then, when it's like, okay, so now guess what? It's time to use more than one MySQL database. Okay? So where's that concept in Rails? It's not there. Where's concepts around data partitioning or developer having an easy way of deciding what's important data or not? Not there. And it's not there in really any framework. So, anything else? Yep.
So you mentioned the DTrace that's in Leopard. Is that the same DTrace that's in Solaris 10, or is it a different implementation of it? Or
it's different. So the question is DTrace in Solaris the same as DTrace in Leopard? And the answer to that would be that they're different. So DTrace, as far as how do you implement a dynamic tracing framework for a given kernel, and for user land software is DTrace, but those implementations in those two different kernels are different. But they have the same API, the same interface, and everything else. So it's the same kind of thing where even though Linux is different and from Solaris is different from these various other things, they all have a C API as being a fundamental feature of Unix. So the implementations are different, but the sort of front end that you interact with is the same.
So they just demonstrated with the OS X Leopard, would those same functionality, would that functionality still be available in Solaris?
So as that base example I wanted to present, that would be. When you start getting into deeper things like memory leaks and that sort of thing, you do write platform-specific things to probe that because they're different. Yeah?
I could be confused, but I think when I signed up for this, there was going to be a case study of Twitter and Scalability.
Yeah, but so I don't work at Twitter. Can't. I had them as a customer for 2 years. So, yeah. But a lot of the examples I gave, you could plug stuff in if you want. Maybe, maybe not. I mean, yeah.
So what's your attitude towards Ruby? You seem you came off a little negative.
Oh, not negative at all. No. I mean, pragmatic, realistic. I think Ruby's great. I think all languages are great. Just think that if you ever do something because you're going to do it in Ruby, you're actually just a hobbyist who wants to play around with a given type of hammer. They're not really interested in building a house. So Ruby's a tool, just like a lot of other tools are. And talking about tools are fine, but fundamentally we should be talking about what we're building and how we're building it. And the truth is that a community is never served by being negative or mean, but it's also never served by being very optimistic about it. And so the fact is that Ruby release management is unprofessional. Sorry. Nothing, no knock on the language itself. Every app I have is in Ruby. Got lots of Ruby stuff. But there's also things that I think that one sort of looks and says what you want to do, and if Ruby isn't right, you can make it right or do something else. But it's it's what you're doing that matters. So, but Ruby's great. I've loved it for a long time. I always call it Pearl's prettier younger sister. So, anything else? Okay, there's food. So, thank you.
Again, thank you, Jason, for coming. Everybody else.